So, the first one is process can fail. What do you do with it? Because your web app might crash for a certain reason that you are not aware of, or even machines can fail. So, which means there is no notion of availability, because real time means we are continuously making the data available or the analytics is available. So, these are two important stuff, right? And because of that computations is lost and your real time liveliness is lost, right? So, these are the first set of problems. So, now how do you survive process failures? So, one simple way to do it is run multiple instances and load balance across them, so that even one web app is down, you can go to the other web app, and they are doing essentially the same thing. And similarly, you can do the Java and Python backend as well too, and they are just doing redundant computation continuously. But any given, assuming that they are going on consuming the data at the same rate, you should be able to get the analytics from one of them at least, right? And the second option is you can replicate the web server, because web server is all stateless. On the other hand, you do not have to replicate the Java Python program to do the same work across multiple machines. Instead, you can write to a MySQL or a Postgres database as a key value store kind of equivalent, and whenever the web server requests the data, then you can pick it up from the MySQL Postgres. So, those are very simple things that you can do to make it your solution more sturdy. And again, what are the issues with this solution? I think I guess one of you already told that scalability is one of the biggest problems. Yes, as you can see, you can't process data at scale. So, the whole idea is like we get a large amount of data. So, we get around totally like around 600 to 700 million tweets every day, and how you can keep up with it, because you have to look at all the tweets in order to figure out whether those URLs are there or not, right? Let us say, for example, your input data rate is 10,000 tweets per second. Your Java or Python backend is capable of doing only like say 1000 tweets per second. That is a processing rate. Now, so like it takes 10 seconds to even process 1 second worth of tweets. So, which means like you will be, but at the end of 10 seconds 90,000 tweets are going to be backing up already. So, which means it is kind of, because your processing rate is much lower than the input data rate, and you are going to keep backing up always. So, you will never catch up with the input data rate, right. So, that is an issue. And if you look at this simpler example, so there are two cases that you have to consider. One is your input data rate is less than processing rate. The next one is when the input data rate is greater than the processing rate. And so, when the input data rate is less than the processing rate, yes, that Java/Python backend solution will work very easily, because I am able to control it. And when it goes beyond that, that is where the problems occur. And this is a simple exercise, but I think this is pretty straightforward for you guys to do it. And so, if your input rate is 500,000 tweets per second and your processing rate is 10,000 tweets per second, how many seconds does it take to process 1 second of input? So, how many tweets will be waiting in the queue at the end of processing? Any ideas?